Be covering some geometry things today, so bring your geometry questions. Geometry. I forgot how to spell geometry for a hot moment. I think that's right. I also think it's wrong. I can't spell. I suck at that. I'm dyslexic. Here we go. We can do algebra next time, and maybe some geometry and algebra will mix together here, okay? All right. So, let's do this. Someone was specifically asking about circles, so I want to start there with talking about the different things about a circle. All right? And actually, we're going to take it back a hot moment. We're going to cover just very basically, we're going to take it back to the most basic, right? We're going to take it back to the most basic of geometry, of area and perimeter. And then we're going to apply that to the circle, okay? Just to make sure that we all know what we're talking about, right? Because if we don't know what we're talking about, there's no point in even talking about it, even if you can do the higher up math. So I always say, start at the bottom, work your way up. Let's go. All right. So, ooh, I've got this cool rectangle. Pretty sick Why are you doing that? Stop it right now. All right. We got this super cool rectangle, right? Let's say I want to find the perimeter and the area of it. We'll apply some things to it. Let's just say it's 2, 4, because that makes my life super easy. We're going to add some measurements to it because it should have measurements. We'll do meters because I hate the filthy imperial system. All right. Are we in this view? That's a little better. Okay, my dears. So, if I want to find the perimeter of something, what I'm really asking is like, let's say I wanted to build a fence around this yard. That is what perimeter is asking. It's asking for how much fencing I would need for this yard. How much do I need to build up around it? How much around the outside? Around the outside. That's what perimeter is. Okay? So what we're going to do is, because I know this is a rectangle, I know that the opposite sides are equal to each other. That is a property of a rectangle. The opposite sides are congruent. They are the same. So if this guy is 2, I know that this guy is 2. If this guy is 4, I know this guy is 4. My opposite sides are congruent. Perimeter is simply asking me to add up all of these sides. That's all it's asking. Awesome, you guys are getting it? Beautiful. We add it all up. The perimeter is equal to 4 plus 2 plus 4 plus 2. And even if this wasn't a rectangle, any shape that we're asking the perimeter of is asking for what it is around the outside. I'm going to back this up a little bit because I'm not getting everything in the shot. We're also trying to shoot from a different location today because moving this thing around is hard. Little better. All right. So I'm going to get 4 plus 2 is 8. No, it's not. It's 6. I can do math. 4 plus 2 is 6. 6 plus 6 is 12. So 12 meters is how much the outside is. Awesome. All right, moving on to that area. Area is asking me basically how big the yard is, how much space I have. Perimeter is around the outside, how much fence I need. Area is how much does it take to fill it. And we discuss area in terms of squares. How square? But we always discuss area in terms of squares. Always, always, always. We discuss it in terms of squares. So, here's how this ends up looking like, okay? We are going this 2 meters is saying I've got 1 meter, right? And then I've got another meter. So I'm just going to break that up. I have 2 meters long, right? 1 meter, another meter. Here I have 4 meters. So I'm just going to break up that measurement so I can see those 4 meters. One meter, 2 meters, 3 meters, 4 meters, right? That's what it's saying. And the total area is the total number of squares that I am getting within that shape. Whatever shape it is. Whatever shape it is. We're bringing it back to that rectangle just because it's really easy to see, right? But that's all I'm ever saying, is that I want to know how many squares it's taking up. And that's also why we express it in terms of square units. Because I'm literally counting squares. That's what an area is. You are literally counting squares. And that's why we express it as a square. Okay? So here, we could just straight up count them, right? There's enough to count. 1, 2, 3, 4, 5, 6, 7, 8. It's going to be 8 meters squared. That's the square root sign. And that's why we do that, is it's literally 8 squares. It's literally 8 meters of squares. That's it. If I didn't want to count these all up, I can multiply. I can do 2 times 4, and I get 8. So that's what we're doing. That's why that works. What grade do I teach? I've taught anywhere from 6th grade to 12th grade. And I've also tutored college, so I got you. It's just squares. So yeah, we're bringing it back to that very simple thing, okay? Does anyone have any questions on that? Perimeter, round the outside. Area, literally counting the squares. Literally counting the squares we make. All right, you ready to spice it up? All right, let's do it. Let's do it. Sniffles today. All right, so now that we've discussed what these measurements are saying, what these basically mean, we're going to take it to some circles, because people had questions about circles in my inbox. Again, if you ever have questions that you want to see covered in the lives, the best place to send your questions is to my DMs. That's where I will check and see what's popular. Okay? So, let's just take some time to talk about circles. It's okay. They're not that bad. Circles aren't that bad. Because we're just going to remember what area is and perimeter is, and we're going to apply that to now a round thing. It's kind of creepy because it's squares within the round, but it's going to be okay. You're going to be okay. I need to clean my board. Squeak, squeak, squeak. Oh, this eraser needs to be cleaned. Give me just a second. All right. So now when it comes to circles, we first have to start by talking about, we need to talk about the number pi, right? Pi is everywhere in circles. Pi. Kind of looks like that dude. And pi stands for 3.14159. Why did I take it out this far? Usually when we talk about math, when we talk about pi in some of our basic classes, we only bring it, I'll use my red, we only bring it to this place, right? This is probably where you're used to seeing pi end, 3.14. Technically, yep, someone keeps writing digits in there. Technically, it goes on forever and ever and ever and ever and ever, and it's never going to stop. It's never going to stop. Pi doesn't stop. Pi is like, can't stop, won't stop. We're going to keep going. But we do not have the time. We do not have the time nor the energy to constantly deal with pi's overdramaticness, right? So we go, we're going to cap you, pi, and usually we talk about 3.14. My point in bringing up the 3.14159 is if you ever start doing anything in science, right? If you wish, I'm going to lean against this wall. If you ever wish to pursue a science career, you want to go into more science classes, typically where you would round it then is to this digit, 3.14159. Okay? So that is where you should think about keeping it. If you want to continue into science and mathematics, this is typically where you keep it. For today's purpose, and for most math classroom purposes, you will keep it at 3.14. Just keep that in mind as something moving forward. All right? And the reason why it goes out just a little bit more is because it increases the accuracies of our measurements, right? Every little bit out we go increases the accuracies. But at a certain point, the amount that we're adding is so little, so negligible, that it doesn't really matter. It's not that big of a deal. Yes, I have taught calc. So typically we keep it at 3.14. You probably won't see it ever go past 3.14159. Cool. Good talk. All right. So let's keep it going. Let us talk. You know, some of you are like, I know it. At that point, it's just extra, you know? Oh, pi, you so extra. All right, let's keep going, right? Let's talk about them circles, shall we? All right. Boop, 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 boop. Boop, 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 boop. Why am I using sound effects? I don't know, but I like them, so we're gonna go with it. Oh, that one got weird. First, we're just gonna talk about the anatomy of a circle. Haha, anatomy. All right, so we're just gonna talk about the anatomy of a circle. It kind of looks like a Pokeball. Yeah, that's fun for me. All right, anatomy of a circle. What do we call the outside of the circle? Does anyone know what we call the outside of the circle? Or the measurement of the outside of the circle? Don't get anxiety. Take a deep breath. It's going to be okay. This is a low pressure situation, okay? Awesome. It's the circumference. And I'm seeing some other perimeter. That was such a good guess because we just talked about how the outside of other shapes were called the perimeter, but circles are extra. Circles are so extra. I feel like circles would be like one of Mike's favorite shapes because they're just so extra. Also, every time I roll my eyes, my contacts like go weird. So I'm gonna try not to do that anymore. But they're super extra. So we call the outside of our circle our circumference. I don't know how to spell it. Can someone spell it out for me? I'm really bad at spelling. I'm so sorry. Circumference. Sorry. Thank you. Circumference. I'm sorry if I ever misspell anything on here. I'm very bad at spelling. So we call the outside of the circle our circumference. All right. This is the center of our circle. Awesome. From the center of our circle, half of my circle, halfway across my circle, is called my radius. That's my radius. All right. All the way across the circle, all the way across it, is my diameter. Diameter. So if you cut a circle in half, straight across it is your diameter. Come on. Give me the marker. Sound effects help. Sound effects always help. This is my diameter. And these are the three things that we're going to be talking about today. You guys are always so sweet. Oh gosh, there are 800 of you right now. That's a big class. All right, so we are going to start with talking about how we calculate my circumference, okay? How do I find the circumference? Thank you for the rose, love. So I find the circumference of a circle by doing my diameter, which I'm going to express as an uppercase D. That's how people will do it. It's my diameter times pi. That was a really bad pi symbol, but we're going with it. That's how we find it. And the reason why this is how we find it is because sorry, I blanked on words for a hot moment. That's all the words I know. I ran out of words. The reason why we find our circumference, sorry, that's written so badly, by diameter times pi is because the amount of times, if I took a string, and you can do this with literally any circle, okay? Any circle this is going to work for, and I think this is so cool. This is where we get it. This is where we get pi from, okay? You take the diameter halfway across your circle, and it is going to fit around your circle, the diameter, not one time, not two times, not three times, but three and a little bit more. And you want to know how much that little bit more is? It's 1.149. So we got it once, twice, three times, and 1.149. And that's pi. Pi is just that measurement. Hey, friend, pi is just that measurement of how many times the diameter goes around your circle. How much all the way across goes around the outside, around the outside, around the outside. That's all it is. That's pi. Pi isn't this mystical, magical number we pulled out of nowhere. Pi is that ratio. It's always been ratios. You can do this for any circle. Absolutely any circle in existence, this works. right? People are like, this is basic math. How did I not know that? And that's why I'm saying some people come on here and they're like, this is so easy. Why would I pay attention to this? And it's because if we don't understand our groundwork in mathematics, if we don't understand what's right there, how are we going to build off of it? And that's the building blocks of mathematics. We need to know what's there, and then we build on top of it. And when we build on top of it, we can make amazing things, like what we are doing right now. This is all because of mathematics, that you are able to tune in and listen to me. And actually, one of the big things that does that is fractals, which we can talk about if you guys want to. But it's so cool. So always start with your basics. Take time, even if you're in college level mathematics right now, take the time to remember your basics and remind yourself. Because I have taken many math classes where I just didn't know why I was doing it. Could I find the calculations? Absolutely, but I didn't understand what I was calculating. And if I don't understand what I'm calculating, what's the freaking point? What's the point in doing any of it if you don't know why? I should be a teacher. Sorry, I'm laughing because I am a teacher. I'm a teacher who for some reason finds it really fun to teach more for free on Saturdays, dressed as a fictional character. So I'm glad you all get something out of this. Could we do trigonometry sometime? Absolutely. Let's do trigonometry sometime. Not sure we'll get to it today, but let's cover it sometime, okay? Cool. Nice. All right, so that's all this is, okay? So that's a way to remember your circumference equation, because that's what it is. That's where we derived it from. The way around a circle is just the diameter and how many times it goes around. It takes 3.14159 diameters to make it around any circle, no matter what the measurement is. And that's pretty dope. All right, another way we could write this, you may see it this way, so that's why I want to bring it up, is I can also write this equation as 2 times r times pi. And don't panic about that, because it's actually not that different, all right? All that this guy is saying, this 2r, is I got it from diameter, because how many radiuses does it take to make up the diameter? It takes 2 radiuses to equal 1 diameter. So that's where we got that from. 2 times your radius times pi is your circumference, because 2 times your radius is just your diameter. And the diameter is just 3.14159 spaces around your circumference. That's it. Nothing mystical or magical. All right, we're going to talk about then the area equation for a circle, and then we're going to try them out, okay? Sound good? Yes, the radius is half of your diameter, because your radius is the measurement from the center of your circle to the outside of your circle. And the diameter is all the way across your circle. So this is just center in is radius. So that's why the radius is just 2 of your diameter. This is a radius, and this is a radius. I hope that's helpful. I'm glad I'm tempting you to go into cosplay. All right, so now we're going to talk about the area equation for a circle, and then we're going to try some of them out, okay? We're going to practice them. So cool. I'm glad some of us are finding this helpful. My face is itchy. All right. So now my area equation. And remember, circumference is just a fancy word for perimeter for a circle, because the circle had to be extra, right? And you can remember that because the circle is clearly the gayest shape. There's no straight lines. I think I'm funny. Yay, gay pride. The circle is Bakugo, gay and extra. Oh, that was funny. I was gonna say it's like Mike, but you know, and I mean, it's like a record too. I can't prove you wrong. I can't. All right. So how I find the area of the equation is sorry, I'm still laughing about that. That was good. That was good. Also, I'm loving the amount of like pride flags that are popping up in the chat. That's fun. All right. The area of a circle is pi times your radius squared. It is pi r squared. And there is a very dumb way that I remember that it's pi r squared. The very dumb way I remember that it's pi r squared is pi r squared. No, pi is round. Yeah, it's a bad joke, but it helps me remember it 100% of the time. And yes, I am a math teacher. I have a degree in mathematics. I have a BA, a 4-year degree in just mathematics, and I remember the area of a circle with that stupid joke. Pi r squared. No, pi is round. You're welcome. All right, but should we talk about why it's actually pi r squared? It's not stupid, it's efficient. Thank you. All right, let's talk about why it's pi r squared, right? Math puns are, Mike. You're right, Crow. The reason why it's pi r squared. Oh, let me get up and erase some things on my circle for you quick. Is the same reason for just kind of how we find an area in general. Gotta do me a little bit of erasing. The reason a way you can remember that it's pi r squared is, let's think about what we're actually doing here, shall we? It kind of looks like a clock. Okay, so this is my radius, right? And this is my radius. I'm just going to label it R for radius, right? It's half of my circle. So a radius is measuring half of my circle. And when I am doing, we'll just start with this part of the equation, r squared. What am I actually doing with that? When I say r squared, I'm saying r times r. My radius times itself, right? That's what I'm doing. So I'm saying, and when I do something times itself, right, I'm actually finding the area of a square. That's actually finding the area of a square, not a circle. I'm now giving everyone on this app flashbacks to the circle equals square situation, right? So I am technically finding a square, the area of a square for this part. Let's say that for some reason it's 2 by 2, just for an example. All right, I am finding this area. All right. So I have technically found this. And then I am now going to multiply that by pi, right? That 3.14159. Or we can think about that, right? We just talked about that that's actually the ratio of how many diameters it takes to go around your circle. We are multiplying it by how many it takes to go around the circle, right? So I'm basically saying I've got 3 more of these. If I multiply it, sorry, I went over. I shouldn't have done that. That was not an accurate representation. Sorry for my messy drawing. We've done 3 of these. And so I've got 3 of them, right? But then I've got this extra space. So we're just doing a little bit more. We're doing that 0.14159 of it more. Now, you'll notice that I haven't quite gone all the way around my circle with it, right? Yeah, you're like, there's a 4th part. But the extra parts, these parts outside of the circle, these guys are going to fill in this leftover space. And that's where I get the equation for a circle. Okay? I am taking that radius, squaring it, and then I'm doing it by how many diameters it takes to go around. Math is freaking cool. So these aren't just crazy things we pulled out of nowhere. They all work together. That's what we're doing here. And you thought we were just covering basic equations, didn't you? That's just, it's so neat. It's so neat that this is how we got it. Math is just one big puzzle we're putting together. Every piece does have a point. Every piece is building off of itself. And every piece has a really cool reason why it works. It's not like we think of it as like these solid building blocks that are just dead, right? They're just these written in stone rules that some old dead guy made up a long, long time ago, and now you're forced to learn it in your math class. But really, it's this neat, constantly changing problem, and we're taking tools and creativity to try and solve them. There is no mathematics without creativity. There is no mathematics that isn't really weird and neat. It just gets presented very dryly. I do have a YouTube channel. I post all of these lives up on my YouTube. You can find that link in my link tree in my bio. Math has never actually made sense before. I hope it's making sense now. I hope this is helping a little bit. All right. So we're going to now take this and we're going to just practice some problems with it, okay? Yep, so if you can fill it out on what you missed. So if you ever miss part of the live, you can go back to my YouTube channel and I post these and you can rewatch them. I hope that's helpful. I think I have one up on fractions. I maybe don't. I know I've talked about fractions before. I have no use for this info, but I'm loving it. That's okay. Hey, maybe you can use it when thinking about different projects you're planning out, Crow, with sewing and how much fabric you need. It does have many applications. Have I done triangles? We can start to talk about some triangles if we have some time after this, okay? Do you have any proofs? We can talk about proofs sometimes. Again, if any of these things we don't cover today, which I can't do this forever, I usually try and stay on for only an hour. Please send a DM with your questions to my bio. I mean, not my bio, my account, and I will take a look at them. Okay? And I do whatever's kind of most popular so we can help as many people as possible. All right, let's do some problems. Ready? All right, let's go. I'm scratching my wall. Erase. Oh, where's my husband when you need him? Oh, bad jokes. Come on. All right. I need to clean this whiteboard after today, don't I? It happens. All right. Thank you, Murder Maven, for moderating. We all love you. Also, thank you, the adorable one, for moderating. You guys are beautiful. Adds whiteboard cleaner to Amazon list. You all are killing me with that stuff. I hope you know that. Oh no, I keep on getting marker all over me. Luckily, these gloves are black. That's why I have to teach in the black ones. All right. Circles. All right, my dears, here are some problems. I'll bring it a little closer while you solve them. Give them a try. All right, I've mixed up radius and diameter. Give them a try, and we're going to go over them in just a bit, okay? So try these out. Hope we can see them okay. We've got 3 meters, 5 meters, 2 centimeters. Give it a try. Try and solve these. Try and remember our equations we just talked about. C stands for circumference and A stands for area. Find me my circumference and my area using the equations we just talked about. You can leave your terms in terms of pi. That's okay. I'm glad this is helpful. All right, let's talk about this first one, shall we? First one, let's talk about it. All right, so we want to find the circumference. Sorry, the light's getting a little reflective on the board. We want to talk about the circumference of this guy. How do we find the circumference again? The circumference is our diameter, right, all the way across the circle, times pi. So in this case, you are given the radius. And how long is the radius to the diameter? It's going to be 2 times r times pi. Or in other words, we've got 2 times 3 times pi. So we get 6 pi meters. Remember to label how far it is. You could have multiplied by pi, but you don't have to. Your teacher will tell you if they want you to or not. But always remember to put your measurement in. And since circumference is measuring the length around the circle, we leave it in terms of meters. Sound good? Pi is 3.14159. It's right up at the top of the screen, love. All right, and we did go over how we got pi earlier, so if you need to go back and watch this once it's up on my YouTube, please feel free to, okay? But we're gonna keep moving. All right, the next one, we're gonna find the area of it. Remember, our area is pi r squared, and we just went over why that is my area. So we have pi r squared. We have our radius, so that's going to be pi times 3 squared. What is 3 squared? What is 3 squared? Beautiful, my dears, it is 9. So we have pi times 9, or you can do 9 pi. Both is good. Meters squared, because remember, we are counting how many squares fit in that circle. That's what that meant. Always remember what you are counting. So we got to put the little square up there. All right, let's do the next guy. Doop, doop. This time, I've given you a diameter. I have given you a diameter, which makes the first problem, what's the circumference, very, very easy now, doesn't it? Awesome, it's 3.1. Oh, you're saying for the other one. Yeah. And you could have multiplied that pi out with it. I like to leave mine in terms of pi because I think it looks a lot cleaner. But if you need to, you just multiply it out with it. Good question. Right. Yes, that means that r would be 2.5. Nice job. For this first one, though, it's very easy when you have the diameter, right? Because our circumference is our diameter times pi. So the circumference here is literally diameter times pi. We got it. It's 5 pi meters. That's all she wrote, folks. That's all, folks. Awesome. So then the next one, perfect, perfect, perfect. You guys are beautiful and wonderful. You're coming in with that next area answer. I'm loving it. I don't know why I'm dancing, because I am. All right. So the next one for the area is pi r squared. We need to get our radius because I gave you the diameter. And the radius is just half of the diameter, right? It's just half of the diameter. So we're going to cut it in half, and we get 2.5 meters is my radius. That was easy. So we're going to do 2.5 squared times pi. All right, can someone tell me what 2.5 squared is? It's not going to be a very nice number. 2.5 times 2.5, what's it gonna be? I was a math major many years ago. I am not that young. Awesome, 6.25, beautiful. So it's 6.25 times pi meters squared. Gotta put that square in there. Again, you can multiply it out with a square. You can multiply it out with pi. You do not always need to. You can express your answer in terms of pi. There might be situations where it is best to multiply it out, but you don't have to all the time. Cool. All right, let's get this last one in, all right? It is. It's not that bad. I feel like math is a lot of us overthinking it and kind of getting freaked out, but it's not always that hard, right? It just looks really scary. But once we understand the basic building blocks behind it, it's nice. It's nice. All right, let's do this last one, and then I'm going to get going, my dears, because I'm tired. All right? Overthinking, I would never. I know, Crow, you never overthink. I overthink constantly, all the time. Meep. All right, last one. 2 centimeters. So I get my circumference. Awesome, beautiful, beautiful. I am getting some beautiful answers. You get your circumference by doing by doing your diameter times pi, or in other words, 2 of your radiuses. My radius is 2 centimeters, so my diameter is 4 centimeters. So 4 centimeters, we'll leave that off for now. 4 times pi, it's just 4 pi centimeters. It's expressed with just the centimeters because it is just the line around the circle. Nice job, everyone. Nice job. All right. So now let's do the area. I have my radius, which makes life easier. So it's 2 squared times pi. And 2 squared, wow, in this case, it's just the same thing now, isn't it? Sometimes that's neat. 4 pi centimeters squared. But the point of why I wrote this one down and brought up this 4 pi centimeters as my circumference and my area is 4 pi centimeters squared is because that's measuring 2 very different things. Those are 2 very, very different measurements there. And that's why this square is very important, because one is telling us the space it takes up, and the other one is telling us a length, right? The length around. So you need to make sure that square is on there. And remember, we put that square because we are literally counting how many squares can fit inside of that circle. The area is pi r squared.